If you heard only one thing about black holes, it's probably that once inside the black hole's event horizon, nothing, not even light, can escape. At which point, it's natural to wonder, if nothing can escape a black hole, how could we ever observe them? How do we even know they exist? Only things inside the event horizon are stuck. Black holes also gravitationally pull on stuff outside the event horizons, and by looking at that stuff, we can get a really good sense that there is a black hole nearby. For example, lots and lots of stars orbit in pairs, but we also see stars orbiting things that aren't normal stars, but instead emit crazy amounts of X-rays. And X-rays in space often come from dust and gas that get superheated while spiraling into a dense, very heavy object. Anyway, by figuring out the mass and orbital characteristics of the stars whose emit X-rays, we can determine how heavy the partners are. Some partners are lightweight enough to be neutron stars, but neutron stars can only get so big before they collapse in on themselves. Theoretical calculations put their upper side limit at around 2 or 3 times the mass of the Sun, and the biggest one we've observed all fall inside that limit. And yet, there are plenty of stars whose orbit clearly shows that the X-ray emitting partners are 5 or 10 times the mass of the Sun, and we simply don't know anything else this could be other than black holes. Sometimes you don't even need an orbiting star at all, and just the X-rays and radio waves from the hot inflating material can be used to determine the mass of a solitary non-star object. In some cases, they turn out to be neutron stars, but in others, they out to be way too heavy and can only be black holes. There are also objects at the center of lots of galaxies that emit lots of X-rays, radio waves and infrared radiation, but not much visible light, and we know that these objects are stupendously heavy because of the way that nearby stars and hot glowing dust orbit them. These orbits tell us the objects are both so heavy and so small they can't possibly be a star. The only thing they could be is supermassive black holes. For example, in the middle of the Milky Way, there is an X-ray, radio wave and infrared object called Sagittarius R star, with nearby stars orbiting it in such small, fast orbits that we know it weighs 4 million times as much as the Sun. And finally, we've also directly observed on multiple occasions gravitational waves that were emitted from the collisions of two very heavy objects. Some of those waves could only come from collisions between objects far too heavy to be anything but pairs of black holes merging to become single, bigger black holes. To quote an astronomer, we have strong confidence that black holes, or at least objects that have many features of black holes, exist. In other words, if it looks like and acts like a black hole, we call it a black hole.